everyone, welcome to my channel.
In the past video, we saw about the 9th module of the ISS, the Quest Airlock. Today we are about to see the next module made as a research facility and docking point for the Russian orbital segment, the PIRS docking compartment.
Let's start the video.
The PIRS, also known as Docking Compartment 1 on the International Space Station, is similar to a combination of USB cable that connects only one type of port together and facilitates transfer of important data. It can attach spacecraft such as Soyuz and Progress resupply crafts to its docking port in the Russian orbital segment, allowing the advancement of technology aboard the Earth orbiting laboratory while also facilitating connection to spacecrafts and also enhancing the sustainability of the station. This module also facilitates EVAs from the Russian segment, allowing for repairs and maintenance of the Russian orbital segment, thus improving the operational capabilities of the entire space station. PIRS, as part of the contribution from Russia to the International Space Station ISS program, was manufactured and launched through collaboration among various entities including Roscosmos, Arctic Energia, and other space agencies and contractors. Roscosmos, as a lead agency, oversaw the project's development and integration, ensuring that PIRS met stringent spaceflight standards. Arctic Energia, a major aerospace manufacturer in Russia and contractor for many space agencies and missions, played a significant role in fabricating and assembling and testing the PIRS. This partnership underscores the collective effort and expertise from multiple organizations to design, build, and deploy the PIRS. PIRS was launched in Assembly Mission 4R aboard the Soyuz U launch vehicle. The launch took place on September 14, 2001 from the Baikonur Cosmodrome in Kazakhstan. During its launch aboard the Soyuz U rocket, the PIRS module was attached to a modified version of the Progress spacecraft known as Progress DC-1 or Progress MSO-1, housed within the rocket's fairing. This modified Progress 11F61 5A55 spacecraft provided the propulsion and guidance necessary to transport PIRS to the International Space Station ISS. The Soyuz U was chosen as a launch vehicle for this mission as it was the primary launch vehicle for both Progress and Soyuz spacecrafts. The docking of the PIRS module to the International Space Station ISS was a crucial milestone that expanded the station's operational capabilities. Now let's see the docking in depth. The PIRS module's journey to the ISS was no ordinary mission. It was transported by a specially modified Progress spacecraft, Progress MS-01, as said earlier, which functioned as a space tug. This dynamic duo executed precise maneuvers, synchronizing their trajectory and velocity to align with the ISS's orbit. This complex procedure, also known as rendezvous, required exceptional precision and coordination. The onboard guidance system of the Progress spacecraft meticulously charted the course, while ground-based tracking facilities continuously monitored the positions and velocities of both the spacecraft and the ISS to ensure flawless synchronization. As PIRS approached the ISS, the Russian Zvezda module equipped with a docking port located at the nadir Earth-facing side, adjusted its orientation to facilitate a perfect docking. With precise alignment achieved, the drogue part on the PIRS made contact with the passive port's cone on the Zvezda module. The cone allowed for the drogue part to slide inside the cone, allowing for corrections of any misalignment in the docking. This was followed by the docking mechanisms engaging securely, firmly connecting the two structures. Upon successful and verified docking, the Progress spacecraft detached from the PIRS and undocked from the ISS, eventually re-entering the Earth's atmosphere. PIRS, now an integral part of the station, served for nearly 2 decades as a docking port for Soyuz crews and Progress cargo ships. PIRS docking compartment is a crucial module of the ISS designed to support spacewalks and spacecraft docking. Now let's explore its components in more detail. Docking ports. The PIRS module featured a docking port located at the nadir Earth-facing side. This port was designed to accommodate Soyuz MS and Progress MS spacecrafts, facilitating the transfer of crew and cargo to and from the ISS. The docking port played a crucial role in ensuring a steady flow of supplies and personnel between Earth and space station. Airlocks. Equipped with 2 airlocks, the PIRS module supported spacewalks, extravehicular activities or EVAs for cosmonauts wearing Russian Orlan M spacesuits. These airlocks enable cosmonauts to exit and re-enter the ISS for maintenance. The first spacewalk from PIRS, a Russian-made airlock on the ISS, occurred during Expedition 3 on October 8, 2001. This was the first EVA after the Progress MS-01 spacecraft attached the PIRS docking compartment and airlock to the Zvezda module on September 17, 2001. Cosmonauts Vladimir Dizhiro and Mikhail Turin conducted the EVA, marking the first extravehicular activity from the space station without a space shuttle present. They wore Russian Orlan spacesuits and carried out several tasks, including installing cables between PIRS and Zvezda to enable spacewalk radio communications, as well as handrails and an exterior ladder on PIRS to assist future spacewalkers. Additionally, they installed a stellar cargo crane for moving equipment outside the ISS. This EVA highlighted the new capabilities of the PIRS docking compartment and airlock, demonstrating its crucial role in supporting spacewalks independently of the space shuttle. Fuel transfer system. The PIRS module was equipped with a sophisticated fuel transfer system. This system allowed the transfer of fuel from the tanks of a docked Progress resupply craft to the integrated propulsion system of the Zvezda service module or the Zarya functional cargo block. Additionally, it facilitated the transfer of propellant from Zvezda and Zarya to the propulsion system of docked Soyuz and Progress vehicles, ensuring efficient fuel management and operational readiness of the ISS. Stellar cargo cranes. Two stellar cargo cranes were added to the PIRS. One during the Expedition 3 EVA-1 and another during Expedition 4 EVA-1 when the stellar cargo crane previously attached to the PMA-1 was moved to the PIRS docking compartment on the Russian orbital segment. These cranes were instrumental in handling and positioning cargo outside the ISS. The PIRS module had a length of 4.91 meters, 16.1 feet and a diameter of 2.55 meters, 8 feet 4 inches. It weighed 3,580 kilograms, 7,890 pounds and provided a pressurized volume of 13 cubic meters, 460 feet. These dimensions made PIRS a compact yet functional addition to the ISS, enabling it to serve multiple roles effectively. On July 14, 2021, Roscosmos announced the decommissioning of the PIRS docking compartment, a key component of the International Space Station ISS for nearly 2 decades. The decision to decommission PIRS was driven by the need to make way for the Nauka module, which was said to expand the station's capabilities. PIRS had served as a vital docking port and airlock for Russian Soyuz and Progress spacecraft, supporting 52 spacewalks and facilitating crucial cargo and crew missions. Its departure was carefully orchestrated with the module scheduled to undock from the nadir port of the Zavesa service module on July 23, 2021. On July 26 at 13:55 Moscow time, 6:55 AM EDT, PIRS along with the Progress MS-16 cargo ship undocked from the ISS. The undocking occurred while the spacecraft was orbiting over eastern China, allowing for real-time communication with the Russian ground stations. Following undocking, Progress MS-16 executed a brief separation burn to increase distance from the ISS before initiating the deorbit maneuver. This maneuver was meticulously planned to guide the PIRS and Progress track into a controlled re-entry over the Pacific Ocean, thereby minimizing risk to inhabited areas. And the module and cargo ship duo re-entered the atmosphere at 17:42 Moscow time, 10:42 AM EDT, after a 17.6 minute burn. Throughout its operational period, totaling 19 years, 313 days, 9 hours, 50 minutes and 45 seconds, PIRS had been instrumental in station's operations. Its decommissioning paved the way for the Poisk mini research module, which was installed at the Zvezda Zenith port in November 2009. The Poisk module, equipped with similar functionalities and 2 EVA hatches, continued to serve as a docking compartment, maintaining the critical docking and airlock functions essential for the ISS operations. In conclusion, the PIRS was an essential part of the International Space Station, enhancing its docking capabilities, supporting numerous spacewalks, and ensuring efficient fuel management. The docking port facilitated seamless cargo and crew transfers, while the airlocks enabled cosmonauts to perform critical extravehicular activities. The sophisticated fuel transfer systems and stellar cargo cranes further improved the station's operational efficiency. Manufactured by Arctic Energia and based on a proven design, PIRS provided reliable service for nearly 2 decades. Its compact yet functional dimensions allowed it to integrate seamlessly with the ISS, exemplifying the achievement of international cooperation and engineering in space exploration. I hope this video on the PIRS docking compartment was interesting and informative. I'll meet you in the next video with another interesting ISS module. Take care, bye.